Right, here we're looking at the Level 2 Maths and Statistics Probability Methods exam sat at Nelson College for our practice exams for the 12 MSN course. This is question 2. Okay, what do we got? It's a normal distribution question. Perfect. Okay, so we know the mean is 20.5 and the standard deviation is 2.1. That's going to be our key information. What proportion of economy checked-in baggage, let's just check, John class passengers, checked-in luggage, okay, so the same, is between 21 and 23. Okay, first up, always give a sketch of the distribution. So I know that the mean's 20.5 and the standard deviation is 2.1. And I want the proportion or the probability that's between 21 and 23. So just roughly drawing it, say that's 21 there and 23 there. Okay, your picture doesn't need to be to scale, but you want to indicate, make sure you're sure for yourself which portion under that normal curve you're determining the area of. Remember, the area under the curve is the probability. Okay, so I'm going to use the formula. It's actually given to us on our formula sheet. Okay, to standardize, the standard normal is x minus the mean over the standard deviation. So I can turn this normal distribution into a standard normal distribution. Okay, similar sort of shape. The mean's going to be 0. The standard deviation is going to be 1. And I'm looking at this bit here between Z1 and I'll call them Z2. Okay. Now what's Z1? Well, I'm really working out how many standard deviations away from the mean is 21. So Z1 equals 21 minus 20.5 all over 2.1. Okay, so 21 minus 20.5 divided by 2.1, so 0.238, and remember, go 3 decimal places, yeah? Always work your Z values to 3 decimal places. And Z2, okay, how many standard deviations away is 23 from 20.5? Well, it's 23 minus 20.5 over 2.1, which equals, okay, got it again, 23 minus 20.5 divided by 2.1, so that's 1.190. Again, you want 3 decimal places. Right, so we've standardized from the normal distribution as given to our standard normal, which means we can now use our tables down here. So let's have a look. I want to be between 0.238 standard deviations and 1.19 standard deviations. So I'm really looking at the probability that 0 is less than Z is less than Z2, which is 1.190, minus the probability that 0 is less than Z is less than Z1, which is 0.238. Okay, because my tables, remember, give me from 0 out to Z2 and from 0 out to Z1. So if I take 0 out to Z2 and take off 0 out to Z1, I will get my correct answer. So let's just make sure we get this right. The probability that the bag weight is 21 is less than weight is less than 23. It's the same as my standardized figures. I can look these up in my tables. So I want to look up 1.19. Okay, I grab my tables, I come down to 1.1 and across to 9, and I've got 0.3830, and then 0.238, I want to come down to 0.2, across to the 3, and then I want to use these differences for 8. So in the same row, because that third place is 8, 0.2, 0.38, it's going to be 0.0910 plus this 31, so 0.0941. Just grab the calculator, we'll work that out. 0.3830 minus 0.0941, 0.2889. Okay, so that's my proportion between 21 and 23. The plane had 376 economy class passengers with one checked-in baggage. Okay, so 376. They had one each. So I was guessing that means there's 376 bags. Passengers with any checked-in luggage is overweight. So overweight is greater than 23. Charge 200. Okay, what is the expected income? So I need to work out the probability of the bag being overweight, and then I can work out how many bags I expect out of the 376 to be overweight, and then apply the charge. So first of all, I'm going to find the probability of overweight bag. Okay, we'll draw a little picture. Again, oh, that's a shocker. Okay, I want my weight over 23 kilos. So I want this bit out here. Okay, now we've got 23 kilos down here, and we also use 23 kilos up here. So I know straight away that my Z value is my Z2 from above, which is 1.19. And I know that the probability that 0 is less than Z is less than Z2 is, where was that? That was there, 0.3830. So the probability that Z is greater than Z2, because remember my table's given me from the mean out to a value, I want it from that value further out, is 0.5 minus 0.3830, which is 0.5 minus 0.3830, 0.1170. The reason it's 0.5 minus that, remember the normal distribution is symmetrical, so half's below the mean, half's above the mean. So the probability of being above the mean, for any value above the mean, is 0.5. And I'm taking out the probabilities from the mean up to 23, or the proportion from the mean up to 23. So that there really is my probability of an overweight bag. So my expected number now, how many bags do I expect to be overweight? Well, there's 376 bags, 0.1170 probability of overweight, so I'm expecting that many. N times P, I've got those round the wrong way here, but that's alright. So if I take that figure I've got before of 0.117 and I multiply by my 376, that'll give me 43, I'm going to say 43.992, 44 bags. So there'll be 44 bags overweight. So the income for the airline equals 44 bags times $200 a bag, which is 44 times 200. Could have done that in my head. $8,800. Could have, should have done that in my head. Okay, let's keep going. What do we got here? 3% of the economy passengers checked in luggage was defined as underweight. They get a free gift. So 3% are underweight. They get a free gift. So calculate the maximum weight can be if we only get a free gift. We call this an inverse normal problem. So instead of working out the probability we're greater than a particular weight, we're told the probability and we need to find that weight. So let's draw a picture of the situation. Here's our normal curve, our normal distribution of bag weights. Okay, and Again, our mean is 20.5. And somewhere down here there's a maximum weight. Let's call that W. That's W. And below that are 3%. Okay. If this portion is 3%, this portion here must be 47%. Okay. So how many standard deviations from the mean away am I? Well, I want to cover an area of 47%. So if I look in my tables now, and instead of looking around the edge, I'm looking in the body here for 47%. The closest I can get to 47% looks like right there, and I'll chuck in a difference. Okay, so to get 47%, I need to be 1.881 standard deviations away. 1.881. Now it's going to be negative because I'm to the left of the mean. So my Z value equals negative 1.881. Okay. When my Z value is negative 1.881, what does that tell me about my weight? Well, my weight is 1.881 standard deviations less than the mean. So W must be the mean minus 1.881 times the standard deviation, which was 2.1 if we look back on the previous page. Okay, so that's going to be my maximum weight for getting a gift. So let's do that. 20.5 minus 1.881 times 2.1 equals 16.55. Now to one decimal place, 16.499, isn't it? So to one decimal place, it's 16.5 kilograms. So that's my maximum weight of my bag. Okay. Oh, now we're looking at carry-on, not checked luggage. So carry-on, the mean is 6 and a standard deviation of 1.2. The middle 50%. Okay, again, let's draw a picture. Now, one of the great things about the normal distribution is that it's symmetrical. So the middle 50%, there'll be 25% there and 25% there, and it's centered around 6. Okay. How many standard deviations away do I have to be to get 25% between the mean and that value? So I'm really thinking about this for my standard normal, aren't I? Yeah, some Z value that gives me 0.25. So similar to the one above, I'm going to look up in the body of my table for 0.25. Okay, 0.25. 2486, and if I chuck on a difference of 13 there, that'll make it 2499. That's pretty close. So I'm 0.674 standard deviations. Okay, so Z equals 0.674. So my two values for the bag here and here are going to be, so what do we call W1 and W2? W1 is 6 minus that many standard deviations, and the standard deviation here was 1.2, and W2 is 6 plus that many standard deviations. And now let's just work those out. 6 minus 0.674 times 1.2 is 5.19, and 6 plus 0.674 times 1.2 is 6.81. So middle 50%, between 5.2 kilograms and 6.8 kilograms. Ooh. Okay, it says there's a C for this. There is a C. So quite a long question. Probably important to look ahead and see where you're going. The airline claims that less than one... Oh, hang on, let's read the context. Once the plane arrives in Auckland Airport, passengers have to wait for their checked luggage. The graph below shows the time passengers had to wait for their checked-in luggage. Okay, so this is waiting on the conveyor belt. Should have to wait. The airline claims that less than 1/4 of the passengers have to wait more than 13 minutes. Okay, use the graph to comment on the validity of this claim. So out of all of our passengers, the ones that are more than 13 minutes, okay, so more than 13, that's 57 plus 50, which is 107. How many passengers altogether? I'm guessing that's our 376. Is it? Let's just check. Out of 17 plus 46 plus 81 plus 102 plus 63 plus 57 plus 50 equals plus 46 plus 81 plus 102 plus 63 plus 57 plus 50. Oh, it's at about 416. So that's looking pretty close to the that quarter mark, isn't it? Okay. Probability wait greater than 13 minutes equals 107 over 416, which equals 25.72%. Should have to wait. So that's my figure. I want to compare it with the quarter, so I'm just going to say so slightly more. More than claimed. Okay, so I worked it out. More than 13, there were 107. Altogether was 416. So the probability of waiting more than 13 minutes for your bag, 107 out of 416, or 25.72%. That's slightly more than claimed. Okay, now Stewart believes that the waiting times displayed above could be modelled with a normal distribution with a mean of 11.75 minutes and a standard deviation of 1.65 minutes. Okay, we want to discuss shape, centre and spread and include some calculations. Okay, so shape. This distribution's got a bit of a bell curve shape to it. So yeah, it's bell curved. It's got one peak, it's unimodal. But it's not really symmetrical, is it? It's slightly thicker in this portion and this portion. So, you know, I'd give that 2 ticks for normal and I'd give that a cross. Okay, centre. The middle, the median, and what's really my experimental data is going to be my 208, 209th point, i.e. so if I start counting up from the bottom, 17 plus 40, I want to get to about 28, 209, 17 plus 46 plus 81, what am I up to now, 144, so that gives me to 144 there, and I need to know about another 60, so I'm just over halfway through there, aren't I? So, you know, the centre is between 11 and 12, and that kind of compares favourably with the normal mean of 11.75. And also the mode, we could use the mode as the centre. So comparing between what we're seeing here and there, if I wanted to get even fussier, I'm 60, from 144 to 208. I'm another 62 of the way through, so I'm, you know, 60% of the way through that group, so 11.6. We don't know how they spread between 11 and 12, but you know, as an idea, it's about right there, so it's pretty good fit, bell-shaped and unimodal. It's pretty good there. What else have we got? Spread. Okay, my normal distribution, remember, goes on and on in theory forever. For normal distribution, normal distribution goes wider. Okay, if I look at plus or minus 3 standard deviations, which should give me approximately 100%, you know, it's just a little bit under. I'm looking at a spread of range, gee, there's not much space to write all this, equals 11.75 plus 3 lots of that, so 11.75 plus, let's go for minus 3 times 1.65 to 11.75 plus 3 times 1.65. I.e. 11.75 minus 3 times 1.65 is 6.8. So it's a bit lower than that minimum of 8 we're given here, up to 11.75 plus the 3.65, 16.7. So i.e. wider than observed data. So I've looked at a shape. I want to say something about the bell curve unimodal. It's not symmetrical. We've got that there, so that counts against. I've looked at the centre. The median's around, you know, in that same region, so that's pretty good. And I've looked at the spread. We should get nearly 100% of it in 3 standard deviations. We get slightly less, and I've gone much wider than this data I've been presented with. Okay, let's see how we went. I think that's the end of it. Let's see how we went on the old mark schedule. Ooh, one question. So, first up, pretty straightforward. Yep, getting that probability. That was all or nothing really for that one, so that was my little U for that 2889. And then this probability here in the second part, that would give me a little U, and actually getting the expected value of 8,800, that would give me my little R. Again, you don't get both the U and the R, you just get the R there. Over the page, maximum gift weight, you've got 16.5 kilos, so the value of K, which is kind of weird. I'm guessing there they wanted this Z value, but we'll never know. I think that there really is the relevant part there for the U, and this piece here would again get your R. Remember, you don't get both of them. Okay, and then the carry-on luggage, that middle 50%, so getting either of the Z values would give you a U, so we'd get one for that. What else have we got going on here? We've got getting the minimum or the maximum, so either of those would give you an R, and both of those would give you the T. So looking at that claim of 50%, just comparing that with the slightly claimed, so that probability there would give you the U. Comparing it with the claim, even just saying slightly more, would give you the R. So close but slightly more would give us the R. Sorry, I keep shoving the piece of paper out from under the camera. And then finally, the sort of things for supporting, they've got unimodal. Okay, let's zoom this up a bit here. Here we go. So what sort of stuff have they said? Roughly symmetrical. Okay, wouldn't get that one. Unimodal we'd get. Yep. General statements. I wonder how many is that. Statements giving some values in comparison between the histogram given the suggestion that normal distribution 2 or 3 shapes. Statements. Okay, so it's going to come down to how many statements you make and using the correct terms. So the median, we've got that statement there. Okay, so that's going to give us a big one. We're going to give, they've actually worked out some probabilities of being in certain areas, of being in these different pieces up here. We haven't done that, but we have looked at being within 3 standard deviations either side. So I definitely get a couple of ticks on there. I reckon it's pretty strong, and I did it myself. I'm going to give it a bit of a T. A little bit subjective, but remember, if it asks you to comment on shape, center, spread, and include some calculations, you've got to do all those to get the marks. All right.